Assalamualaikum warahmatullahi wabarakatuh. This is the last tutorial class for this semester. I mean for this subject PTK. So I'm going to discuss with all of you regarding question number 9 and also question number 10. These questions have been explained in goals. However, I would like to highlight several more things. That's why I have repeated this video. In more details, and also I will give at the end of this video I will give you several tips for your test too. Okay, so let's start. Okay, the question is, this is question number 9. Steam at 5 bar absolute with 2 to 5 degrees C of superheat is fed to a turbine at 1000 kg per hour. Okay, so we know that we have 5 bar steam, we have steam at 5 bar absolute. Okay, what does it mean? Okay, we'll look at it later on. Then 2 to 5 degrees C, okay, of superheat is fed. So this is the feed of turbine, and then this is the flow rate, mass flow rate, right? Okay, the turbine operation is adiabatic. Okay, whenever we see this term, we know that Q will be equal to 0, and the effluent is saturated steam at 0.013 bar. Effluent means the output. Okay, this is the output, where the condition for the output is steam. Okay, saturated steam is very important. Okay, at 1.013 bar. Calculate the work output. We need to find the work output, okay, by neglecting delta EK, which is delta EK equals 0, delta EP equals 0. Okay, so let's look at the solution. Okay, so by looking at the, sorry, I need to move this one first. Okay, by looking at the energy balance equation, this is the energy balance equation. We have learned about this previously. Okay, okay, we know that EK, EP, Q is 0 because of the information given in the question. So we will be left with these two terms only, in which we know that this is specific enthalpy. Specific enthalpy means we need to have this mass flow rate. Okay, mass flow rate. Okay, this is specific enthalpy. Okay, and this is work flow rate, shaft work. Okay, okay. So what we need to do now, is we need to know how to get this part. Okay, why in the question it mentions about 2 to 5 degrees C, but how do we get this 151.8? Why do we need to add 2 to 5 with this value? Okay, so actually if we go to the steam table, okay, at 5 bar, yeah, okay, we go to the steam table at 5 bar. So we know this is, if you look at this table, properties of superheated steam. Okay, so even though it mentions about superheated steam, but we know that this part is saturated water or saturated steam, the initial part. That's why we need to refer to B7, because if we go to B6 or B5, we cannot get pressure more than 1 bar. Okay, I will show you the table. Okay, this is B5. The pressure is up till 0.18 only. Therefore B6 1.0 and 0.4. So we need to have pressure at 5 bar. Okay, 5 bar. That's why we need to go to superheated steam, even though this is it mentions about saturated steam, something like that, right? So we still need to go to superheated steam. And then one more thing, here it mentioned also about superheat, right? So we know that we need to refer to superheated steam table. So if you go to this steam table at 5 bar, which is this part, okay, here we have saturated temperature. So when it mentions about 5 bar absolute, okay, absolute means you need to consider absolute, sorry, absolute means you need to consider this saturated temperature value. So we have the info that steam at 5 bar absolute with 2 to 5 degrees C of superheat. In other words, actually we need to add both values, 5 1.8 with 2 to 5 degrees C. That's why in the solution we need to find 2 to 5 plus 151.8. We got 376.8. At 5 bar, how to do it? That means we need to do extrapolation because the value is 376.8. So here we have 350. 376.8 is something around here, right? So we know that we need to refer to this whole part, okay, 5 bar, okay, and then we just need to focus on the enthalpy, because if we go back to the formula, the energy balance, we have mass flow rate, and then we also have enthalpy. So we need to consider this, okay. That's why we are going to do interpolation on the enthalpy only. Enthalpy means the first part. The second part is internal energy. The third part is specific value, volume. So we are going to look at this. Yeah. So if we do interpolation, let's sketch a simple graph. Okay, here we have, sorry, let's say this is our um, temperature. Okay, so we have temperature. If we look at this part, we have 300. We can look at 300. You can always go to 250, 50, 75, 100 to get to sketch the graph, but it's easier if you look at the value which is next to each other. So we have 300 and 350, and then the enthalpy is 3065 for 300 degrees C. For 350 degrees C, 3168. Okay, so what we need to do now is we just put the value 3065. Okay, let's say this is our enthalpy, this is our temperature. It is 3065, 300 degrees C. Okay, we have something here, 1 point here, degrees C. This is, then we have 350, 3168. So we have second point. Then we have third point, which is at 376.8. Okay, so the value, we need to find something. We need to find this value, I mean. So we have this value that need to be found. However, we know that this is a straight line, then we will have M1 and also M2. Okay, from this point to another point, from this point, okay, let's say A to B, B to C, right? So A to B is our first gradient. So we have M1. We can do like this: M1 equals M2. Okay, so M1 is 3168 minus with 3065. Okay, we have learned about how to find gradient in our secondary school. So we have 350 minus 300, because the first point A is, the point is what, 300. Okay, A we have 300. If we plot that we write the coordinate 300 3065, right? B we have 350, okay, x, then the value of y is 3168. Then here we need to find y, x is 376.8. We need to find y. That's why we got this. We can do like something like this, okay? So we take the value of y, we need to find minus with 3168 over, since we use these 2 point B and C, so we can do y minus with 3168 and then 376.8 minus with 350. If you solve this, you will get the value of y is equal to 3223.2. Okay, then if you get this value, then we go back to the solution. Okay, here we get this value. Okay, and then H out, because effluent, right? Effluent H out, the condition is at 1.013 bar saturated steam. So again, we cannot get the value of saturated steam at 1 bar because the highest is, just now we have checked, not more than 1. So we need to look at this steam table, okay? I mean the superheated steam table, the value of 1 bar, and then we get this value of enthalpy 2675. So here we have 2676, so some almost similar, right? Okay, here 2676, and then we can use this formula where we know the flow rate is 1000 kilogram per hour. 1000 times with, actually this is from this, okay, we solve this 3.7 or 0.7 or 0.3, doesn't matter, okay, minus 2676, and then you, when you solve this, and then you times convert the unit to per second, because we need to find in kilowatt, so we will get this value 152.2.